Section 2.1, the remainder theorem. So we're going to look at long division once again. Long division might be something you last did in elementary school when dividing numbers. But we can use it to divide a polynomial by a binomial factor. The number used to divide is called the divisor, as you may recall. And the result obtained is called the quotient. The number left over is called the remainder. Okay, so in quotient form, we can, the division of a polynomial, we'll call it p of x, by a binomial of the form ax minus b can be written as the polynomial p of x divided by x minus b equals its quotient plus its remainder. And then the corresponding statement that we can use to check the division would be the polynomial equals that divisor times the quotient plus the remainder. Okay, so just to kind of recall how we did long division back when we divided just numbers. If you had a question like 16 divided by 3, well, you ask yourself, how many times does 3 go into 16? Well, you would say it's 5 times. So, and then you multiply the 3 times 5 to get 15. Subtract the 16 and 15 and get a remainder of 1. Okay, so 16, which is your dividend, divided by your divisor, which is 3, equals the quotient 5 and a remainder of 1. Okay, written in quotient form, that would be 16 divided by 3 equals 5 plus 1/3. And, you know, why 1/3? Well, remember, it's quotient and remainder. It's not 5 plus 1. That would be 6. Wouldn't make any sense. It's quotient plus the remainder, 1. If you were to continue the division, it would be 1 to continue to be divided by the divisor 3. So it's 5 plus 1/3. And if you were interested in checking the division, then you multiply your quotient by the divisor, 5 times 3. Add your remainder, you should get the original dividend once again. So the same thing that we can do here with numerals can be done with polynomials. So before we get into that, there is a theorem we have to talk about, and that is the remainder theorem. So the remainder theorem says that when a polynomial function, p of x, is divided by its factor, the remainder is going to be the polynomial evaluated at b, okay, where b is that constant term in the binomial factor. If the binomial factor has a leading coefficient of a, so ax minus b, then the remainder is p of b over a, where a and b are integers, and of course a cannot be 0. And this is an important theorem because it's going to help us find divisors when it comes time to dividing higher degree polynomials. So we'll keep that in our back pocket. We'll do some examples on that later on, but actually, let's look at an example right now, actually. Determine the remainder when f of x, this is a polynomial function, is divided by x minus 1. Okay, and instead of carrying out the division completely, we can just simply apply the remainder theorem that says that if you take 1, right, the value of b, and you plug it into the function, that will tell you the remainder. The remainder is -4 when you evaluate the function. Okay. Similarly, if you divide that same function by x plus 2, you take the value of b, which is -2, and you put it into the function and evaluate it, and you get a remainder of 0. Okay, so what does the significance of 0 mean? Well, if you don't have a remainder, then we can say that if we took this polynomial and divided by x plus 2, the quotient we get, well, will be another factor of this function. We can find additional factors of a function, or we can put a function in factored form because there's no remainder, right? Imagine not having a remainder, right? You would have common factors. You'd be evaluating a quotient with common factors. But okay, maybe we have to kind of go through the whole motions and carry out polynomial division to see for ourselves how this all works. Okay, So I'm going to show you how we can divide a polynomial by a divisor, by a binomial divisor here, x plus 2. So 2x cubed minus 3x squared plus x minus 6 is the polynomial you want to divide. And we want to divide it by x plus 2. Okay. So I'm going to write it in a way that's kind of looking like the good old long division, right? So I start by writing the polynomial. Let's switch that back to black ink. So 2x cubed minus, let's get some more room actually. 2x cubed minus 3x squared plus x minus 6. And I'm going to draw my kind of division organizer here, and then my divisor is going to go here on the left, x plus 2, like so. Okay. And so the way this works is that I start with x and 2x cubed. Okay. So I'm going to write down, what do I have to multiply with x so that I get 2x cubed? Well, if I did 2x squared times x, I get 2x cubed. So that's the beginning of our quotient here, right? 2x squared, right? And 2x squared times x is 2x cubed. I'm going to write that down here right below. Okay. So I already figured out one part of our quotient. And that 2x squared, I also have to multiply it with the 2, right? So 2 times 2x squared is going to be 4x squared. And that goes right beside the 2x cubed. So plus 4x squared. Okay. So now I'm ready to sort of find what remains. Okay. So the idea is you're going to subtract these terms, right? So 2x cubed minus 2x cubed is 0, which is expected. Okay. And then minus 3x squared, take away 4x squared, it's going to be minus 7x squared. And then the rest of the terms carry down. Okay, so now the next step is to look at minus 7x squared. What term, when I multiply it by x, gives me minus 7x squared? That term is going to be minus 7x, and that's the next term in my quotient. So I'm going to write down minus 7x, multiplied by x again, it gets me minus 7x squared. And I take that same minus 7x multiplied by 2, I get minus 14x. Was I? No, okay. And then I'm going to carry down the minus. Sorry, let's not carry down yet. Let's subtract these terms here. So again, I'm going to subtract that. So 7x squared minus, sorry, negative 7x squared, take away negative 7x squared, cancels out. That gives me 0. Then x take away minus 14x is going to become 15x. And I carry down the 6 once more, so that becomes minus 6 here. Okay. And then I ask myself, all right, what term when I multiply it by x gives me 15x? And that's just going to be 15, so plus 15. Okay. And so that gives me 15x. 15 up here times, so we have to multiply by the divisor again, so 15x, and then 15 times 2, which is 30. And then I subtract 15x, take away 15x is 0. Minus 6, take away 30 is minus 36. And there is our remainder, minus 36. Okay, so the result in quotient form then will be 2x squared, 2x cubed rather, minus 3x squared plus x minus 6. I'm writing the dividend once more, divided by the divisor, x plus 2, equals the quotient. And so what's our quotient? It's up here, 2x squared minus 7x plus 15. So 2x squared minus 7x plus 15 plus our remainder, or I should say minus our remainder 36 over x plus 2. Okay, and that is how we divide the polynomials. In part B, write the corresponding statement that can be used to check the division. So here, the corresponding statement simply says, well, let's review what the corresponding statement up here is. So corresponding statement, divisor times quotient plus the remainder in this form. Okay, so let's write that down. That polynomial dividends of 2x cubed, what's it again, minus 3x squared plus x minus 6 equals that divisor x plus 2 times our quotient. You said it was 2x squared plus 7x plus 15 plus our remainder minus 36. Okay, so it's just taking this form, quotient form, if we multiply both sides by x plus 2, what we get is this form, right? There's your x plus 2, the x plus 2 is gone from that term, and they're gone from the left side as well. Okay, so let's just erase that, just so in our notes we're not confusing that as quotient form. All right, there you go. Okay, and then we can identify restrictions. Because we are dealing with division of polynomials, we have to be aware of what are our restrictions. And those restrictions come from any denominators that we see, and the denominators that we see here are x plus 2. So x plus 2 cannot be equal to 0. Therefore, x is not equal to negative 2. Okay, so that's one example. Let's have a look at some more. Part number 2. Perform each division, express the result in quotient form and the corresponding form. Actually, just before we get into that, I want to just go back to remainder theorem again. Remember remainder theorem? Could it have predicted the remainder? Right? If I took the value b, so here b is negative 2. Remember x, let's call it, so when a polynomial is p of x is divided by x minus b, right? So x minus b equals x plus 2. So b equals negative 2. Okay. And then if I said, okay, p of negative 2, what is that? 2 times negative 2 cubed minus 3 times negative 2 squared plus negative 2 minus 6 equals negative 16 minus 12 minus 2 minus 6, which is negative 36. There it is. So the remainder theorem could have predicted that remainder for us. Now, it depends what we want. Like, what if we still wanted a quotient, we still have to carry out the division, right? But if we just wanted the remainder, we don't have to carry out the division. We can just use the remainder theorem to get that answer. Okay, back to the next question. Number 2, perform each division, express the result in quotient form and the corresponding form. So 4x cubed plus 3x minus 4 divided by 2x plus 1. So let's write down the polynomial, 4x cubed. And this time I'm going to put in a 0 term for the x squared term. So 0x squared plus 3x minus 4. Now that's important. Every degree of x term has to be represented. You can't skip. So if there is no x squared term, you got to throw it in there and just say it's 0x squared. Okay. Otherwise, the polynomial division algorithm just wouldn't work correctly. And my divisor here is 2x plus 1. Okay, so my note here, I'm going to say make sure all degrees are shown and in descending order. Notice how I put the order in correct order by the highest degree to the lowest. That has to be done too. Okay. Okay, let me carry out the algorithm, really. Okay, so think of what quotient here when I multiply by 2x gives me 4x cubed. Well, that will be 2 times x squared, right? So 2x squared times 2x is 4x cubed. And then multiply the 2x squared with the rest of the binomial here. So 2x squared times 1 is also 2x squared. Then I can't multiply that quotient anymore. So let's just subtract. So again, we have to subtract for our next term here. Next steps, okay. 4x cubed minus 4x cubed is 0. And 0x squared, take away 2x squared is minus 2x squared. And now everything else can come down. Okay. Next step, think about, okay, 2x times what gives me minus 2x squared? Well, that's just going to be a minus x, right? So minus x times 2x is minus 2x squared. And minus x times 1 is just minus x. Subtract. Okay, 2x squared, take away negative 2x squared is 0. 3x, take away a negative x is plus x. So it's 3x plus x, which is 4x. And then the minus 4 can carry down. And then the last thing, well, 2x times what is 4x? So that's going to be plus 2. And then 2 times 1 is 2, so plus 2. Ooh, okay. And then subtract 4x, take away 4x is 0, and minus 4 take away 2 is minus 6. And there's our remainder. Okay, so remainder equals minus 6. Now in quotient form, we express it like this. So 4x cubed minus 3x minus 4 divided by 2x plus 1 equals my quotient. Again, the quotient is from up here. Oops. Okay, 2x squared minus x plus 2 plus your remainder, so minus 6 over 2x plus 1. And then in the corresponding form, so we can check, we can express this as 4x cubed minus 3x minus 4 equals the divisor 2x plus 1 times our quotient 2x squared minus x plus 2, and then our remainder minus 6. Okay, so again, the only difference between the forms is that I can multiply both sides by the divisor 2x plus 1, so it disappears on the left, and then it appears here beside the quotient on the right and disappears with the remainder. Okay, let's do another one. Notice how order, it's not in order, cube came first, so you got to put it in order. Okay, so start with minus 9x to the power 4, and then we put the plus 6x cubed, and then there's no quadratic term, so I have to put one in there, 0x squared, then plus 6x, and then a minus 5. And then we write our division chart, and then 3x minus 2 for my divisor. Maybe I don't like that. I should use a ruler. Be much more neater if I used a ruler. Use a ruler. Okay. All right. Yeah, it doesn't look good either. Well, okay. We'll live with it. All right, 3x times what gives me negative 9x4? Write that down at the top for our quotient. Well, we're going to need a minus 3, and then we're going to need an x to the power of 3. Okay, that gives me minus 9x4. And then so minus 3x cubed times minus 2 is a positive 6 plus 6x cubed. If I subtract them, I get 0 and 0. Wow. Okay. Let's bring down the rest. 0x squared plus 6x minus 5. And really, I don't really care about the 0x squared at this point. The question is, well, 3x times what gives me 6x? That's going to be plus 2. So let's put a plus 2. So 2 times 3x is 6x. 2 times minus 2 is minus 4. And 6, and so if we subtract 6x, take away 6x is 0. Minus 5, take away negative 4 is negative 5 plus 4, which is negative 1. So my remainder is minus 1. Okay, and then again, write this in quotient form. So I'll put this 9x4 plus 6x cubed plus 6x minus 5 divided by 3x minus 2 equals the quotient. The quotient is minus 3x cubed plus 2. Take away the remainder 1 over 3x minus 2. Okay. And then in corresponding form, we have minus 9x4 plus 6x cubed plus 6x minus 5 equal to the divisor 3x minus 2 times minus 3x squared plus 2 minus the remainder of 1. Okay. Now, there is one question for you to try there, so I suggest you pause the video and come back, and we'll have the answer for you to check. All right, and so here is the answer. I'm just going to leave it in quotient form. If you get it right in quotient form, you probably got the corresponding form as well. So the quotient is 8x squared plus 14x plus 42 with a remainder of 105 over x minus 3. And remember your restrictions, x cannot be 3. Okay. Let's look at another example. Use the remainder theorem to determine the remainder. Okay, so here we have, remember x minus b is a divisor, so it's going to be equal to x plus 1. So therefore, b is equal to minus 1. So check. The remainder theorem says if I plug in minus 1 into my polynomial, p of negative 1, we get 2 times negative 1 cubed plus negative 1 squared minus 3 times negative 1 minus 6. And the answer to this, when I evaluate it, is the remainder. So the remainder is, let's see here, negative 2 plus 1 plus 3 minus 6 equals, let's see, negative 1 plus minus 3, negative 4. There's my remainder. Okay, so the remainder is minus 4. What if we now have a divisor with a coefficient a? So remember, ax minus b equals 3x minus 2. Okay, so this says, well, remember the remainder theorem says the remainder is p of b over a. Okay, so b over a in this case is going to be 2 over 3. So b over a equals 2 over 3. So p of 2 over 3 equals 2 over 3 to the 4th plus 2 over 3 to the 3rd minus 3 times 2 over 3 plus 6. And the resulting answer for that one is 364 over 81. I'm interested in keeping it as an exact value, so I'm not going to turn that into a decimal. Okay, number 4. Determine the value of k when the polynomial 3x to the power 4 plus kx cubed minus 7x minus 10 is divided by x minus 2 and the remainder is 8. A little bit of a thinking problem here, just kind of taking what the final result will be and working backwards. Okay, so if I divide by x minus 2, I'm going to use the remainder theorem to try and determine the answer. So I'm going to say here P of 2 equals 8 by remainder theorem. Okay, so this says 8 equals 3 times 2 to the 4th plus k times 2 cubed minus 7 times 2 minus 10. So 8 equals 2 to the 4th is 16 times 3 is 48 plus 2 cubed is 8, so 8k. 7 times 2 is 14, and then minus 10. Simplifying further, we get 48 minus 10 is 38, minus 14 is 24. So 24 plus 8k. 8, subtract both sides by 24, we get minus 16 equals 8k. And so k is equal to negative 2. Okay. And number 5, give this one a try. Use the remainder theorem to determine the remainder when this is divided by 2x minus 3. Pause the video, try it out, and come back. We'll get the answer. Okay, so hopefully you had a chance to do it and recognize that the b over a value we're looking at is 3 over 2, and you plug that into the function, you get the answer 15, which is your remainder, and that's using the remainder theorem. Okay, so I didn't show all the work here for that, but here's the answer. And that's it. So this lesson is about polynomial division. If you can understand how to divide polynomial with a binomial, and if you can understand the remainder theorem, you've got it. So try some of the exercises from the text and come back with questions, and I will see you in the next video.